Hello again. We are working through the problems for the Math 104 Gateway from the set 23 through 33. And we are working on number 29, which is solving for x in the equation 13x squared minus 11 cubed minus the quantity 13x squared minus 11 equals 0. So what we want to do first is we want to make note that we can use u substitution for the quantity 13x squared minus 11 here and 13x squared minus 11 here. And this will be our u. This will be our u here, which will then give us the equation u cubed minus u equals 0. And with this quantity here, we will notice we can factor out u as a common factor, which then gives us u times the quantity u cubed minus 1, and all that equaling 0. And if we look here at this quantity, u squared minus 1, we will notice that we can use the difference of squares, where u squared is our a squared, and then minus 1 would be our b squared here. And noticing that this here equals a minus b, and then a plus b, we could use that for the following, where u squared minus 1 equals u minus 1, then u plus 1. And putting that together for our expression right here, we then get the following. We get u times u minus 1 times u plus 1 equals 0. So all these factors being 0 would make this 0, as well as all of them being 0 individually. So we get the following possible solutions. We have u equals 0, u minus 1 equals 0, and u plus 1 equals 0. So now we want to isolate u on each side, which again gives us u equals 0, gives us once more u equals 1, and gives us u equals negative 1. And now we want to undo our substitution for our u quantity here, which then gives us the following expressions. It gives us 13x squared minus 1 equals 0. It gives us minus 11. It gives us 13x squared minus 11 equals 1. And then 13x squared minus 11 equals negative 1. Now our goal is to isolate x squared for each of these quantities so we can isolate x for each of these quantities. And this gives us the following. We will get x squared equals 11 over 13. We will then get x squared equals 12 over 13. And then we will get x squared equals 10 over 13. And since we will admit complex solutions here, we don't have to worry about sign, and we wouldn't have to worry about it anyway since they are all positive. But we will have to remember that we have both a positive and negative solution for each one of these quantities, which gives us the following expressions for our final solution. We have plus or minus the square root of 11 over 13. We have x equals plus or minus the square root of 12 over 13, as well as plus or minus the square root of 10 over 13. And this set of solutions here gives us the set of solutions for the problem. And we could check all of these answers, but since we already determined that they were all valid based on our expressions for x squared here, we know that they are all valid solutions for the original equation.